So now we are starting with the second lecture of coordinate geometry. And let's remember, let's recap what we have done in the previous class. So first of all, we went over the syllabus, that is P1. We talked about the coordinate. We talked about distance of a point from the origin, length of line segment, and distance between 2 points. We talked about this formula. We actually derived this formula from Pythagoras theorem. Then we applied this formula to find the distance between 2 points. The questions that we are doing right now, that is the basic type. As soon as we have understood every single concept in detail, we will move to the past paper questions, and then you will see how confident you are, how comfortable you are in solving those questions. And then we talk about midpoint of a line segment, pretty basic. Use the word average. Remember the word average. And then slope inclination, positive slope, climbing up, negative slope, climbing down. Horizontal line, there is no change in height. Vertical line, there is no change in base, no horizontal change. Then the formula, slope inclination, rise over run, gradient, change in y over change in x. The gradient of a horizontal line is 0. The gradient of a vertical line is undefined. Then we talked about how is it undefined. Then we talked about equation of a line, the traditional format that has the slope and the y-intercept, which is called the slope-intercept format, which you have used in either IGCSE or O-level math. And then the new one, y minus y1 is mx minus x1, that is the slope point format. And then we talked about the equation of a line, how we simplify things. If the examiner has asked us, which the P1 examiner usually does, give the answer in a particular form. So we have to give that answer in that particular form. And that was about lecture number 1. So now after recapping, let's start with lecture number 2. So now in lecture number 2, the very first thing that we talk about, that is parallel lines. So if we talk about parallel lines, therefore, let me use a small line over here. This is a blue line. This is a green line. If two lines are parallel, this is L1, this is L2, then the gradients are the same. M1 equals to M2. For example, if there is a line y is equals to 3x plus 5, and this is line 1, just it has nothing to do with the diagram as such, just a line like that. And then there is line 2, which is 2y minus 6x plus 7 equals to 0. And the examiner asks us, are these two lines parallel? So how will we prove this? So this is already in the standard form, y is equals to mx plus c. Just focus on the m. If y is all alone, if y is on the left hand side, if the coefficient of y is 1, then the coefficient of x is the gradient. So I'm just focusing on the coefficient of x, which is 3. So therefore, gradient is 3. Now let me double check. 2y is equals to 6x minus 7. And then let me make y the subject. That is 6x over 2 minus 7 over 2. And then compare with y is equals to mx plus c. Again, the coefficient of y is 1. Y is on the left hand side. The coefficient of x is the gradient. The coefficient of x is 6 over 2. So the coefficient of x is 3. Yes, these two are the same. So what is the conclusion? The conclusion is yes, line 1 and line 2 are parallel. So line 1 and line 2, they are parallel. That is the first basic concept that we have studied today. Now let me make an exam type question out of this. So whenever I'll use the symbol ETQ, that will stand for exam type question. That means it's not a past paper question, but it's an exam type question similar to that. So now let me write worked example 1. Find equation of a line parallel to this particular line, which is 2y plus 3x is equals to 8, and is passing through the point 5 comma negative 3. So now let me change the color of this thing also, and let me change it into blue, and this point is also in blue. So now what do we have to do? We have to find equation of a line. It's parallel to this thing and is passing through this point. So first of all, whenever we are interested in a line, now understand these things in detail. Wherever we are interested in finding the line, we need a point, we need the slope. Now since it's about parallel, the slope will come out of this. 2y plus 3x is equals to 8. 2y is equals to negative 3x plus 8. And then y is equals to negative 3x over 2 plus 8 over 2. Coefficient of x is negative 3 over 2. So that is what we will use. Use slope negative 3 over 2 in bracket, right parallel. They have the same slope. What about the point? The point is right over here. That is 5 and negative 3. So the slope is already found. That is m is equals to negative 3 over 2. The point is here. So now find the equation. So therefore y minus y1 is equals to m x minus x1, y minus minus 3, bracket is equals to m, which is negative 3 over 2, x minus 5. Simplify it a bit further. Y plus 3 is negative 3 over 2 x minus 5, and then stop over here. Why? Because this is all good, all clear. That is the equation. So you have found the equation. Since no particular format was prescribed, was asked for, therefore this is all good, all clear. So this is finding the equation of a line. Let me move to exam type question. And let me just introduce the new concept and then another exam type question. So first of all, now we are talking about perpendicular lines. So what is the concept of perpendicular lines? Let me just draw it. So this is a red line going like this. This is a blue line, and let me just shift it this way. So this is line 1 like this. This is line 2 like this. And line 1 is perpendicular. That is the symbol that we use for perpendicular to line 2. Gradient of 1 into gradient of 2 should give us negative 1. That is the rule that we use. So if two lines are perpendicular, the gradients multiply to give you negative 1. So in other words, one gradient is the negative reciprocal of the other. So that is how we will work out. Now again, let me write line 1. Y is equals to 2 over 3x plus 5. Line 2, y is equals to negative 3 over 2x minus 8. We are checking, is line 1 perpendicular to line 2? Now both equations are in the standard form. This is one line, so this is 2/3, the gradient. The other line has a gradient of negative 3 over 2. Let's multiply it out. 2 over 3. This is negative 3 over 2. Multiply it out. This 2 and 2 cancels out. 3 and 2 cancels out. We are left with negative 1. Yes, L1 is perpendicular to L2. Why? Because gradients multiply out to give negative 1. One gradient is the negative reciprocal of the other. So remember this term, negative reciprocal. So 2/3 and negative 3/2. Yes, they are negative reciprocal of one another. That is why they are perpendicular. So now this thing is done. Let's move on. So let's do an exam type question. So now we are talking about worked example 2. Find equation of a line perpendicular to 3y is equals to 5x plus 1 and passing through the point -2, 5, -2, 4. So now let me just change the color. So these are the two things that we need to look for. So it's passing through the point and it's perpendicular to this. Let me highlight this thing also. And that's how it is. So now, again, you need to find the equation of a line. You need a point, which is -2, 4. You need a slope. Now, this line, 3y is equals to 5x plus 1. Y is equals to 5/3x plus 1/3. The slope of this line is 5/3. But the slope of this perpendicular line, which I am interested in. So let me just focus on this line. I'm interested in this line and this thing over here. Therefore, gradient of that perpendicular line, that should be -3/5. So negative reciprocal of this particular line. So you flip the fraction, you change the sign. If it's positive, it becomes negative and vice versa. So now we have the point, we have the slope, and then y minus y1 in brackets is equals to, let me just make the bracket better, is equals to mx minus x1. Y minus 4 is equals to -3/5 x minus -2. Let's simplify it a bit. Y minus 4 is -3/5 x plus 2. And let's say I need the equation in the form ax plus by plus d equals to 0. So therefore, let's cross multiply 5y minus 20, -3x, -6, 5y plus 3x, -20 plus 6 is equals to 0. Therefore, 3x plus 5y and 20 and 6, the difference is 14 with a negative sign equals to 0. So that is the answer that we got. And this is like ax plus by plus d equals to 0. If they ask for state values of a, b, and d, so a is 3, b is 5, c is -14. It can also be the other way around. Or it can also be -3x, -5y plus 14 is equals to 0. So now a is -3, b is -5, c is, not c, d is +14. So that's how this question is done. Now these were some basic concepts of parallel and perpendicular lines. So I hope everything is clear over here. Let's move on. Now let's talk about equation of x-axis, equation of y-axis. So let me just focus on that. Let me choose a different color. So this is the y-axis. This is the x-axis. So y-axis, x-axis, all along the x-axis. So let me write it. all along x-axis, y coordinate is 0. Therefore, the equation of x-axis is what? Y is equals to 0. Similarly, all along y-axis, x coordinate is 0. Therefore, equation of y-axis is x is equals to 0. So y-axis, x is equals to 0. X-axis, y is equals to 0. Keep that in mind. And let me just write it down like this. So this is equation of x-axis, equation of y-axis. Now let's talk about line meets x-axis, line meets y-axis. Now let's just make an exam type question. The line x plus 2y equals to 10 meets x-axis at A and y-axis at B. Write down the coordinates of A and B. So now let me just write the y-axis. Let me just make it thinner. No, not this. Okay, so that is the y-axis and that is the x-axis. And let me just draw the line for you like this. Let's say the diagram was already given. It's not when x is 0, y is this. Okay, now it makes sense. This line, first of all, how did I draw this line? That's the first thing. X plus 2y equals to 10. When x is 0, 2y equals to 10, therefore y is equals to 5. Then y is 0, x is equals to 10. So now let me write this thing down. Line meets y-axis, then x is equals to 0. And then let me write it down. Line meets x-axis, y is equals to 0. Like this, therefore like this. Why? Because that's the equation. The equation of y-axis is x is equals to 0. The equation of x-axis is y is equals to 0. It's the opposite thing. So we are interested in finding the coordinates of A and B. So coordinates of A when it meets x-axis. So if I focus on this x-axis at A, so this point is A, that means this point is this thing, therefore A is 10, 0. So A is 10, 0. And this point over here, that is B, it meets y-axis at B. So this point is B, and B is x is 0, y is 5, so B is 0, 5. So this B is 0, 5. Is this all good, all clear? And now I can ask you a lot of multiple things. I can ask you the midpoint of A and B, the distance between A and B, something else, something to do with perpendicularity, and so on. So all good, all clear. So now let's take this diagram and let's paste it on the next page to solve further questions based upon this. So if I paste it, no, not this. Where does this come from? So if I copy it like this, okay. So now if I say that, first of all, what are the different questions? Part A, find midpoint of the line find midpoint of the line AB. Yeah. So this is M, and we have, first of all, let me write this thing. A is 0, 5. B is 10, 0. Midpoint, that's the average. So add up the x coordinates and take half. So 0 plus 10 divided by 2. Add up the y coordinates and take half. 5 plus 0 divided by 2. So this is 10 over 2 is 5, and this is 5 over 2. That is the coordinate of M. That is the first basic thing. The second thing that they can ask, area of triangle OAB. O is the origin, and I can say this is O, this is A, this is B. So that's pretty basic. This is, let me just draw a small diagram like this. And then this is the red thing like this. And then we have this purple thing that goes like this. It's not a scale diagram. So this is 5 units. This is 10 units. Therefore, the area is half into 10 into 5. That comes out to be 25 units square or square units. That is the answer for this particular part. Okay, so now this is what you get over here. Let me just pause the recording for a short while. So now, what else can we ask? Let's say, let me draw a line starting from the origin and touching this line, and this line is perpendicular, and let me call this point as C. Now keep in mind, C is not the midpoint, okay? Because it won't be the midpoint because these two lengths are not equal. It's not an isosceles triangle. If this was 5, this was 5, yes, it would pass through the midpoint, but it's not passing through the midpoint. I'm interested in finding the coordinates of C. Now we have the gradient of this line. So the gradient of this line will be negative reciprocal. So part C. We have the equation which is, where it is, x plus 2y is equals to 10. So equation of the purple line that goes like this. This is x plus 2y is equals to 10. 2y is equals to negative x plus 10. Y is equals to negative half x plus 5. The gradient is negative half. Now, if I talk about that green line that's going like this. So let me make it better. That green line that's going like this, and it's making a perpendicular thing. And this is O and this is C. So therefore, gradient of OC should be positive 2. Why? Because it's a negative reciprocal. And we know that the origin is 0, 0. Therefore, the equation is y is equals to mx plus c. Y is equals to 2x plus 0. In other words, y is equals to 2x. That is equation of OC. Now this thing is done. What can we do further? Part D. If I'm interested in find coordinates of C. Now let me highlight this thing. Whenever we are interested in finding points of intersection, it's always about solving simultaneous equations. Even if we have found this thing over here, this y coordinate, y-intercept, x-intercept. So this is the x-intercept. This is the y-intercept. So basically we solved with this equation, we solved with this equation. It is so trivial that we don't feel it. Technically we solved simultaneous equations. We solved this equation simultaneously with this. We solved this equation simultaneously with this. So now if I want the coordinates of this, I should solve this equation simultaneously with this one. So therefore, what we will do is that we have y is equals to 2x and x plus 2y is equals to 10. So we have the purple line, which is x plus 2y equals to 10. That is equation 1. We have the green line, y is equals to 2x. That is equation 2. So now solve simultaneously. I'll just take this y, I'll substitute it over here. So I think substitution seems very easy to me. So substitution, let's use. So x plus 2 times y is equals to 10. And let me use a green marker over here. That is y is equals to 2x. So let me solve it. X plus 4x is equals to 10. And then 5x is equals to 10. Therefore, x comes out to be 2. And y is equals to 2 into 2, which comes out to be 4. Therefore, coordinate of C is 2, 4. I can also find, based upon this, I hope this is all good, all clear. Find the distance from O to C. So therefore, we have O is 0, 0, C is 2, 4. Therefore, OC, the magnitude, that is 0 minus 2 whole square. This is 0 minus 4 whole square, square root. This is 2 square, which is 4, 4 square, which is 16, that's root 20, which can also be written as 4 into 5. I just want to rationalize it, simplify it further. That is root 4, root 5. That is 2 root 5 units. That is the answer. So this is giving the answer in the exact form without rounding off, without using a calculator, leaving the answer in this form. So that is what we have done so far. So just have a good look at this question. It was on 3 pages. So this is worked example 3, I think. So worked example 3, and this is worked example 3 continued. And this is again worked example 3 continued. And over here, we finished worked example 3. So this is where we stop for a while. So now this thing is done. What else can we talk about? So we can talk about this thing. That is the concept of area. Let's talk about concept of area. So if we talk about area of a triangle, and let's talk about the different ways of finding the area of a triangle. So now, first of all, what I can do is that, let me choose this thing. And this is a right angle triangle. So I'm just choosing a base over here. Let me choose another base over here. Let me choose another base over here. And then this is perpendicular like this. This is going like this. And this is going like this. I'm just drawing 3 possible shapes. It's not drawn to scale, so keep that in mind. Okay. Now, first of all, this is a right angled triangle. This one is acute angle triangle. This one is obtuse angle triangle. The blue line is the base in all of them. So that's the base, that is the base, that is the base. In the first triangle, the height is the red one. Why? Because this is perpendicular. I don't see the height. I have to draw my own height. So let me just draw a height like this. I think I'll just choose the purple color. That's good. So this is the height now. And let me just start with this. Okay, that's the height. And over here, that is the height. So over here, this one, that's the height. because it is a must. Okay, height should be perpendicular to base. For area, this is compulsory, this is necessary, this is mandatory. That's the height. Over here, the height is on the outside, and yes, it's perpendicular, but it's on the outside. So in all of them, area of triangle, that is half into base into height. Now, if I use this knowledge in that question once again, and let me draw this. So we have this thing, the perpendicular axis, the horizontal axis. Then we have this line going like this. This point was B, 0, 5. This point was A, 5, 0. That is the y-axis, that is the x-axis. And let me call it worked example 4, the new version. And remember that I found this height as root 20 units, and this is further simplified. Now let's say I have this thing, and now I want to find, let me write it down, just a direct question. Find perpendicular distance from origin to line AB. Now, whether the equation of a line is given or whether I have found the x-intercept and the y-intercept, it doesn't make a difference. This is the reality which you see. Now, if I want to find this perpendicular distance, it's not drawn to scale. So let me just draw a line like this. And this is O. And let me label this point as C. So basically, find OC magnitude. Now, that was one approach that we did. Technically, this is alternative approach to find OC magnitude. Now, let me highlight this. So this is the alternative approach to find this. What we can do is that, let me find area of triangle OAB. That is half into 10 into 5, half into base into height. That comes out to be 25 units square. So this is the base, this is the height, that is the area. Step 2. Now find AB magnitude. I can either use distance formula, I can either use Pythagoras theorem, doesn't make a difference. So now let me just draw a small version of it to give you a perfect idea. This is the blue line. This is the red line like this. And that's the purple line that's going like this. So this is 5, this is 10, it's not drawn to scale. This is A, this is B, therefore AB magnitude, that is 5 square, 10 square, square root, that is square root of 125. Leave it as it is for right now. So basically, let me write down the steps. This is step 1. This is step 2. And now let's move to step 3. What do you think? Can you guess what is the step? I'm thinking in terms of area. I'm thinking in terms of a length. And now OC is perpendicular to AB. So let me just erase the extra stuff. That is this thing. I'm erasing this. Okay. Let me erase the stuff. So now OC is perpendicular. OC is perpendicular to AB. That means I can consider OC as the height. I can consider AB as the base. So therefore the area again can be half into OC into AB. Let me use the symbol for distance. The area still over here, 25 square units. So therefore, let me just pull this thing down over here. This is 25. This is half. OC magnitude is what we are looking for. AB magnitude is root 125. Let me simplify this further. That is 25 into 5 square root. That is root 25 root 5, which comes out to be 5 root 5. So therefore, AB is 5 root 5. Now let me simplify it. So let me add a page. So this is 25 into 2 divided by 5. That is equals to OC magnitude. And don't forget the root 5. I think I forgot the root 5. So 25 into 2, and this is 5 root 5, is equals to OC. So first of all, 25 into 2, that is 50 over 5, that is 10 over root 5 is OC. And if we simplify it, we should get the same answer as over here, which is 2 root 5 units. So right now, let me use the calculator. I'm not intentionally teaching the rationalization at this point. Let me first use the calculator. So first of all, I found OC to be 2 root 5. I think that is the one, if I'm not mistaken. Yes, that is root 20 units. Just think with that. So that is root 20. And now I found OC to be 10 over root 5. So let me use the calculator. So 20 square root, that comes out to be 4.472. So this comes out to be 4.472. And then 5 square root reciprocal into 10 is again 4.472. So yes, these two answers are exactly the same. They look different, but they're exactly the same. So yes, this is another method of finding this distance. Now just have a good look at it, and then I'll teach you how to do the rationalization. So what was the question about? The question was about alternative approach to find OC, the distance from O till C. What is step number 1? Area of triangle AOB, that is 25. Find AB either using distance formula or the Pythagoras theorem. The third step, OC and AB are perpendicular, so the area can also be found out using this. Now let's focus on this. This is the height, and this whole thing is the base. Why? Because this is something like this. This is the height. This whole thing is the base. So as long as the height and the base are perpendicular, you can find the area of the triangle. So I considered OC to be the height, AB to the base. AB is already found over here. And then I simplified it. And right now I'm just using the calculator, and it gives me the exact same answer. I hope everyone is all good, all clear with this. Now, let me add one other segment to it. That is about something called rationalization. So when we talk about rationalization from the perspective of P1, that is getting ing, I got it wrong, getting rid of square root from denominator. So let me highlight it again. For example, we know from indices a power, not this thing, a power m into a power n, that is a m plus n. When the bases are the same, the powers add up. So same base and powers, they add up in multiplication. Everyone knows this rule. Now let me take it further. A raised to power of half into a raised to power of half, that is a raised to power of half plus half, which is a power 1, which is simply a. Everyone agrees with this also. Square root of a equals to a. That's the same thing written in the surd form. So this square root, this is called surd form. And this is something that we have to deal with in every single topic, in most of the topic in P1 as well as P3. Now, if I write square root of 2, that comes out to be 2. Square root of 3, that comes out to be 3. Square root of 5, that comes out to be 5. Now, let's say if I have 1 over root 2, and if I multiply and divide by the same constant, that is multiplication by 1. So let me multiply and divide by root 2. Root 2, what happens is that 1 into root 2 is root 2. But root 2 into root 2, what do we get? We get a 2. Now, someone can say, what difference does it make? Truly, it doesn't make any difference, but that's how the examiner wants it. When we evaluate 1 over root 2 using a calculator, this is 0.7071 and so on. When we evaluate 2 over root 2 from the calculator, it's exactly the same thing. Doesn't make a difference, but this one is rationalized, the other one is not. Let me give you another example. 1 over root 3. If I multiply and divide by root 3, I'm doing the process of rationalization because the root, it disappears because they have the same base and I get a normal number in the denominator. So this is root 3 over 3. That is the answer. Again, if I write 1 over root 3, I think that is 0.577 something. If I write root 3 over 3, that's also the same thing. Again, this is rationalized. Now, this thing will be used a lot in circular measure, which is our next topic. It will be used a lot in trigonometry. It can be used in pure maths 3 in A-level second year a lot, and so on, and a lot of other places. Now, coming back to this. We have root 20, we have 10 over root 5. So let me just equate the two. So this is root 20. This is 10 over root 5. Let me first simplify this. So this is 4 into 5 square root. That's root 4, root 5, which is 2 root 5. That is the simplification on the inside. How can I simplify over here? Multiply and divide by root 5. So that is 10 root 5 over root 5 over 5. The root 5 will make it 5. Now what happens? 5 ones are, 5 twos are, we get 2 root 5. So this answer is exactly the same. The looks are different, but the answer is the same. So that is why you need to learn rationalization. So now what have we learned today so far is that we talked about, let me go back up a lot. Okay, we started with the concept of parallel lines. We talked about an exam type question involving parallel lines. We talked about perpendicular lines. In parallel, gradient is the same. In perpendicular, gradients multiply to give you -1. One gradient is the negative reciprocal of the other. And what else is there? Okay, let me just check one thing. So now, if two lines are perpendicular, the gradients multiply to give you -1. Then an exam question based upon this. In order to find the equation of a line, you need a point, you need a slope. Equation of x-axis, y is equals to 0. Equation of y-axis, x is equals to 0. The detail is over here. Line meets the x-axis, y coordinate is 0. Line meets the x-axis. Line meets y-axis, x coordinate is 0. The opposite. Line meets y-axis, x coordinate is 0. We found this thing. We made a question involving midpoint and area of triangle and finding the equation of a perpendicular, solving it simultaneously, finding the distance. Then we talked about area of a triangle, the different perspective, height and base should be perpendicular. Alternative approach to finding OC. That thing is also done using this thing. First of all, the height and, if you can see my hand, the height and base are perpendicular like this. And then over here, the OC is the perpendicular, AB is the base. So based upon this, we got this answer. We compared it using decimals. Then we talked about rationalization, that is getting rid of square root from the denominator. We used the knowledge from indices. We understood rationalization. And finally, we prove that these two are exactly the same. So basically, that's where we stop lecture number 2 of coordinate geometry, and we'll see you in the next class. Take care.